Hello everyone, welcome to today's lecture. So today we will start with chapter 6, Refraction of Light, Science 1. Okay, page number 73. Can you recall questions? What is meant by reflection of light? This you had learnt last year in your 9th standard about reflection and about concave mirror, convex mirror, the ray diagrams if you remember. Okay, so what is reflection of light? When a ray of light falls on an opaque surface and it is bounced back, then it is said to be reflection of light. What are the laws of reflection? Do you remember? The angle of incidence is equal to angle of reflection. The incident ray, the reflected ray and the normal lie on the same plane, and the incident ray and the reflected ray lie on opposite sides of the normal. These were the laws of reflection. Now this year you are going to study about refraction of light. Before studying that, there are two try this questions given on page number 73. First one, try this. Take a transparent glass and fill it with water. What you have to do, you have to take a glass, fill it with water, and you have to dip a pencil into it vertically. You have to see the thickness of the pencil outside water and inside water. After that, you have to put it slanting, a little slanting. You may see that the part of the pencil which is there inside the water, it will appear to be raised. This you might have observed. Okay, why it is so? The next activity is keep a 5 rupee coin in a metallic vessel. Okay, and if you stand near the vessel, you can see the coin inside the vessel. Now you have to move backwards till a point where you are not able to see the 5 rupee coin. Okay, you have to keep the glass in front of you and you have to move it backwards so that you are not able to see the coin in the glass or in the beaker. Okay, not far away but to a little distance. Then what you have to do, you have to ask somebody to pour water into it. You may see that when the level of water rises, after a particular point, you are able to see the coin at that same position where you were not able to see before. Okay, that means I will repeat. You have to take a glass, you have to keep a 5 rupee coin in it. Okay, you are able to see it. You have to move backwards. You have to stop at that position when you are not able to see it. Immediate position. Okay, not far back. So at that position, you may ask your friend to pour water into it. After some time, you may see that as the level of water rises, a point comes when you are able to see that 5 rupee coin inside it. Okay, so why it is so? Why these things occur? These things occur because the light rays, when it travels from one medium to another medium, it changes its path. That process, that phenomenon, it is called as refraction of light. So we will see what is refraction of light. Light changes its direction when going from one transparent medium to another transparent medium. This is called as refraction of light. This is the definition for refraction of light. Now here they have shown a glass slab. Okay, you have to take a piece of paper. This practical you are having in your practicals, for your practicals, you have to take a piece of paper like this, white paper. On that paper you have to keep a glass slab. There is a glass slab. Here the glass slab is taken as PQRS. It is the glass slab. You have to draw an outline to the glass slab. Okay. If you want, you may see the video of light passing through a glass slab. Refraction in a glass slab on YouTube also. Okay. So there is a glass slab which is kept. You have to put 2 pins, you have to place 2 pins and you have to see from the other side where you are able to see the pin. Okay, if you will be able to see the pin here somewhere, and then you have to draw the lines. Okay, then you have to draw the lines. You may see that AB, it is the incident ray. The ray which is falling on the surface is the incident ray. Actually, if it went straight, it would have gone like this. Okay, it would have the dotted line. It should have gone straight, but it does not go straight. It changes its path due to the phenomenon called as refraction. Okay, here this is the medium air and this is the medium glass. When it is passing from air to glass, that means from a rarer medium to denser medium. Now what do you mean by rarer and what do you mean by denser? When the molecules are away a little bit from each other, then it is said to be a rarer medium. When the molecules are packed, okay, near to each other, then it is said to be a denser medium. Here air is a rarer medium and glass is a denser medium. Now what happens? The ray, this is the ray, the incident ray. This is the incident ray which is falling. This ray, it bends towards the normal. It bends and goes like this. Okay, goes like this and comes out like this. This is called the emergent ray. So this is the incident ray, this is the refracted ray, and this is the emergent ray. This is the angle of incidence. Okay, the angle of incidence. This is angle of refraction and this is angle of emergence. You may see this ray and this dotted line will be parallel to each other. It will be parallel to each other. So what you have to remember in this diagram while drawing, you have to see that there should be a bending here. Okay, there should be a bending here and there should be a dotted line which go straight, and the emergent ray and the dotted line, they should be parallel to each other. Hope you have understood the terms incident ray, refracted ray, emergent ray, angle of incidence, angle of refraction and angle of emergence. What is the important property? The emergent ray will be parallel to the ray, the line which is a dotted line which is drawn. Okay, they should be parallel to each other. Now we will move on to the next topic, that is laws of refraction. For laws of refraction, on page number 74, they have given a diagram in which they have shown a glass slab. The one medium is air, the other medium is glass. They have shown the incident ray, the refracted ray, the angle of incidence and angle of refraction. Angle of incidence is denoted by I and angle of refraction is denoted by R. Okay, understood what is angle of incidence? The angle made by the incident ray to the normal is called as angle of incidence. The angle made by the refracted ray to the normal is called as angle of refraction. Okay, now so laws of refraction. What are the laws of refraction? The incident ray and the refracted ray at the point of incidence lie on opposite sides of the normal. You may see if this is the glass, okay, and this is the incident ray, this is the refracted ray, and this perpendicular line, the perpendicular line drawn, that is called as the normal. The incident ray and the refracted ray lie on opposite sides of the normal. That is the first law. The incident ray, the refracted ray and the normal lie in the same plane. These two are together. Okay. Now the next is for a given pair of media. Here the given pair here is air and glass. Here the given pair is air and glass. So there is the light is passing from one medium to another medium. So there should be two mediums, isn't it? So for a given pair of media, the ratio of sin I to sin R is a constant, and that constant is called as refractive index. Okay, that constant is called as refractive index, which is denoted by eta. This is the symbol showing refractive index, which is equal to sin I upon sin R, where I stand for angle of incidence and R stand for angle of refraction. Okay, this law is also called as Snell's law. Sometimes the question could be to write Snell's law, the second law. This law is also called as Snell's law. Or the question could be what is refractive index? Or the question could be write the three laws of refraction. Okay, you may write this. Next is the topic refractive index. Okay, the refractive index, what is refractive index? It is the ratio of sin I to sin R. Okay, now the next term is what do you mean by absolute refractive index? So we studied that the light has to travel from one medium to another medium. Absolute refractive index means when the light passes from vacuum to any medium, that is said to be absolute refractive index. We will see the refractive index of a medium with respect to vacuum is called as absolute refractive index. You may mark this on page number 74, last paragraph. Okay, it is an important question. What do you mean by absolute refractive index? So what is absolute refractive index? It is the refractive index of a medium with respect to vacuum. That means the first medium is vacuum and the second medium is another medium. You may see on page number 75 they have given a table showing the absolute refractive indices of some media. For air it is 1.003. For ice it is 1.31. Okay, that means for ice, if you consider the light is passing from vacuum to ice. Water 1.33. That means when the light passes from vacuum to water. Next, diamond, when the light passes from vacuum to diamond, that is absolute refractive index. From this table you have to remember the refractive index of water, the refractive index of diamond and the refractive index of dense flint glass. Okay, so you may see diamond is the hardest substance. So as the thickness increases, the refractive index also increases. You may note that from this diagram. Okay, now the next is the relation. Refractive index depends on the velocity of light on the medium. What is the relation between refractive index and the velocity of light? Actually, why do the light bend when it passes from one medium to another medium? Because when the light is passing, there are particles every side. Okay, so if it is a rarer medium, it will move with one velocity. When it enters into another medium, as the particles are packed in other manner, they will change their velocity. Okay, that is why the light bends. The light changes its path. Why the light changes its path? Because the density of different mediums are different. Okay, so the velocity of light and refractive index, there is a relation between the two. Now here this is read as refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. So this is V1 upon V2. You have to learn it like this. Okay, refractive index of second medium with respect to first medium is equal to V1 upon V2, and refractive index of first medium with respect to second medium is equal to V2 upon V1. V1 means the velocity of light in first medium. V2 means the velocity of light in second medium. Here, refractive index of first medium with respect to second medium is equal to velocity of light in second medium upon velocity of light in first medium. This you have to learn. Okay, now there is a can you tell question on page number 75. If the refractive index of second medium with respect to first medium, you may see second medium with respect to first medium is V1 upon V2. That we can write. Okay, you know the equation. If the refractive index of second medium with respect to first medium is refractive index 2, 1, and that of third medium with respect to second medium is refractive index of third medium with respect to first medium. This is second medium with respect to first medium, and this is third medium with respect to second medium. Now the question is, what and how much is refractive index of third medium with respect to first medium? So you may write this is refractive index of third medium with respect to first medium. Now we know, according to the equation, second medium with respect to first medium is V1 upon V2. You may see here. Okay. Third medium with respect to 2 is V2 upon V3. You have to write the part, this one below and this one up. You may remember like that. And the refractive index of third medium with respect to first medium will be V1 upon V3. Now there is a derivation. You have to multiply both numerator and denominator by V2. Okay, you have to multiply both numerator and denominator by V2. Why? Because it is a derivation. You are deriving to some relation. Okay, you have to show something. So V2 upon V2, you will get it as V1 upon V3 into V2 upon V2. This V2 I will take this side and V3 I will take this side. Okay, so it will become V1 upon V2 into V2 upon V3. Okay, so you may see V1 upon V2 is this and V2 upon V3 is this. Okay, so what will be this? The refractive index of third medium with respect to first medium is equal to refractive index of second medium with respect to first medium multiplied by refractive index of third medium with respect to second medium. This you may write in your notebook. Okay, it is an important question. You may copy. Now the next is, when the light passes through different media, then what are the different types of refraction which occur? So I told you there is a rarer medium, there is a denser medium. In rarer medium the particles are far from each other, and in a denser medium the particles are nearer to each other. Now here they have shown, when a ray of light passes from rarer medium to denser medium, the ray bends towards the normal. You may see the ray bends. This is the normal, this is the incident ray, and this is the refracted ray. So it bends towards the normal. When the ray of light passes from denser medium to rarer medium, it passes away from the normal. It goes away from the normal. And if the ray is perpendicular to the surface, that means like that of normal. Okay, if the ray is perpendicular, that is 90 degree, then there is no bending, then there is no refraction, it goes straight. These are the three conditions. I repeat, when the ray of light passes from rarer medium to denser medium, it bends towards the normal. When the ray of light passes from denser medium to rarer medium, it bends away from the normal. If the ray of light is perpendicular, then it does not bend. Okay. Now, if there is a question asked, if there is an incident ray which makes an angle of 30 degree to the glass slab. Okay, 30 degree to the glass slab means, if this is the glass slab, this is the normal, and this is the ray. Okay, it is the ray. This angle will be 30 degree. If this angle will be 30 degree, what will be the angle of incidence? The angle of incidence is this. The angle of incidence will be 60 degree. Okay, so you have to note what has been given in the question. This question is very frequently asked. They give in the question the angle made by the incident ray to the glass slab. Okay, if they have given the angle made by the incident ray to the normal, you have to take that value itself as the angle of incidence. And if they give the value angle of incidence as the angle made by the incident ray to the glass slab, then you have to subtract it from 90. Why 90? Because normal is perpendicular to the surface. Okay, so these things you have to remember in this lecture. You may mark these things in your textbook. Okay, thank you.